In today's video, we're doing another of the most important pieces of Algebra 1. So today we are reviewing something called factoring, which I'm sure many of you will remember how to do once we get started. So when you factor, the first thing that we need to do is label our A, B, and C. So factoring happens when you have three pieces, three terms, a trinomial, and we need to break it down into two binomials. It's the exact opposite of what we did yesterday. So what we have in number 1, when we factor this here, my A, or my number in front, is a 1. There's nothing there, so that's a 1. My B, the number in the middle, is a 7. And my C, my number in the back, is a 12. So what I need to do is multiply my A number times my C number. So 1 times 12 is 12. The easiest way to remember that is that air conditioning, or AC, is blowing from the ceiling. So I take my AC and I put it on the top. B stands for bottom, so I need to put a 7 on the bottom. So now what I need to do is think about factors that multiply to make 12, but would add to make 7. So I'm going to write my factors of 12 starting in order. 1 times 12, 2 times 6, 3 times 4. So I need to see which pair would add to make a 7. 3 times 4 is 7. So now there's a trick when there's an x squared in front, is that if it's only an x squared, if there's no number in front, then all you need is the x puzzle numbers. So if it's an x squared, we can stop here. So my final answer is x plus 3 times x plus 4. So if you double distributed this like you did yesterday, x times 4, 3 times x, 3 times 4, combined like terms, you would end up with this trinomial. So factoring is the opposite of what we did yesterday. So in the first type of factoring, if it's an x squared in front, you do the x puzzle. I got a positive 3 and a positive 4, so I got to go straight into my answer. That only happens, the x puzzle is the numbers only if there's an x squared in the front. So now we're going to do the same thing, but this time we're going to put an actual number in the front and make it more exciting. So the first step, as always, is we need to label A equals 4, B equals 9, C equals 5. So I'm going to draw my x. My A times C goes on the top. A times C is 20. B goes on the bottom. 9 is on the bottom. So I need to figure out what multiplies to make 20 but adds to make a 9. 20 is the same as 1 times 20, 2 times 10, and 4 times 5. 4 times 5 makes 20. So now in this one, I don't have an x squared in front. I have a 4x squared in front. So if there's an actual number in the front, what we have to do next is called splitting the middle. So what that means is the first term gets to stay. 4x, we're going to write that down. Instead of this middle term, we're going to write down the two terms that came from our x puzzle. Whoops. And we put x's with them because they came from the x puzzle, so they need an x. And then I bring down the back term, which is a positive 5. So now what I need to do is draw a line down the middle. So just to repeat, if there is a number in front of x squared, we have to split the middle, which means you put your first term, you put your two x puzzle terms, 4 plus 5 made 9, and then we put our back term. Okay, so now what we have to do is called factoring by the greatest common factor. You're good at this. What is the biggest number I can take out of a 4 and a 4? Well, obviously, a 4. They both have the letter x, so I can remove an x. So in the front, I'm writing 4x. What's left over? 4 divided by 4 is 1. When exponents are stacked, you learned yesterday, you subtract, plus. 4 divided by 4 is 1. When exponents are stacked, you subtract. 1 minus 1 is 0. Now we do the same thing here. The biggest number I can take out of this is a 5. This one does not have an x, so I cannot take an x out. So I just write down the number of 5. 5 divided by 5 is 1. There's an x here, plus 5 divided by 5 is 1. So now when you factor both pieces, what's going to happen is that these are going to match. So my final answer is they both have a 1x plus 1, so I can take that out. And then my front numbers are 4x plus 5. Easy. And this is your final answer. So let's do that one more time together, and then you can try number 4 on your own. So we are factoring this trinomial, which means we need to split it into 2 pieces. The a is 2, the b is 1, the c is a negative 21. I start with an x puzzle. My a number times my c number is the number negative 42. My b, the number in the middle, is a positive 1. I need to figure out what multiplies to make a 42. 1 times 42, 2 times 21, a couple others, 6 times 7. So now to make a 1, if I had a negative 6 and a positive 7, negative 6 plus 7 is positive 1. Negative 6 times 7 is negative 42. Okay, so now I've solved my x puzzle. So now to factor, there is a number in front, so I have to rewrite 2x squared. Next, I have a minus 6x. I split the middle. Then I have a positive 7x. If it comes from the x puzzle, we have to make sure we give it an x. And then the back term is a positive 7. Now we can split the middle and write what that comes out. A 2 is the biggest number that I can divide a 2 and a 6 by. An x is what's in both terms. So I'm going to take out a 2x. My leftovers, 2 divided by 2 is 1. When exponents are stacked, you subtract. Minus 6 divided by 2 is 3. When exponents are stacked, you subtract. It's like something's not right. There you go. Sorry, guys. This back term is a negative 21. Sorry. There we go. Now it's right. So when you split the middle goes here. The front is in the front. The back is in the back. Sorry about that. Okay, a 7 and a 21, what comes out? I can divide them both by 7. The 21 does not have an x, so all I can take out is a 7. 7 divided by 7 is 1. There's an x there. 21 divided by 7 is minus 3. Okay, so now that my parentheses match, I can take out a 1x and a minus 3. Then the numbers that were in front get to go together. A 2x and a positive 7. Okay, when you're ready, go ahead and try number 4. In number 4, be careful if this term is a negative, you'll have to take out a negative with your answer. So if that's a negative, you'll take out a negative when you do this here. This one was not a negative, so I did not have to take a negative out. Okay, go ahead, try number 4. All right, when you're ready, we're going to move to special cases. So easy. So the special cases have to do with something called square roots. You should remember this from when we did it earlier in the year. So in this first one here, when I factor, I know that I'm going to have 2 binomials. I'm going to have 2 parentheses here. So what we have to ask ourselves is what times itself makes x squared. X times x makes x squared. What times itself makes negative 81? Well, 9 times 9 makes 81. To make a negative number, it has to be a positive times a negative makes a negative number. And that is your final answer. So we'll do the same thing with 64, with number 6. We set up 2 parentheses. What times itself makes 64? Perfect square, 8 and 8. There's an x in the first term, so I have to put x's in the first term. What times itself makes 36? 6 times 6. To make this a negative, you have to do a positive times a negative. So 8x plus 6 and 8x minus 6. The next one is the same thing. We read it twice, but we have to be careful with the signs here. So it's the same though, these are perfect squares. What times itself makes x squared? X times x. What times itself makes a positive 9? 3 times 3. But in this type, you just do the sign that's in the middle. Positive 3 times positive 3 makes positive 9. If you were to multiply this out, it would be a 6x, a positive 6x in the middle. So when you have 3 pieces with perfect squares, your signs will be the same. Now I can rewrite this, x plus 3, there are 2 of them. So this is the same as x plus 3 squared. Let's do that one more time. Perfect square. Let's be consistent. All right, what times itself makes 25? 5 times 5 with an x. What times itself makes a 4? 2 times 2. So now in this one, the middle term is a minus. So what that means is this has to be a negative times a negative would make this a positive. But when you multiplied them out, it would make your middle term a negative. So when there's 3 pieces with perfect squares, your sign has to be the same, because now I can rewrite this as 5x minus 2, and there are 2 of them. Very easy. Okay, so moving into the last piece. So you can continue to factor like you have. You do the x puzzle, you split the middle, you figure out what can come out of both. So you can continue to factor by hand if you want to. But just like yesterday, I want to show you how you can do this, where all you have to do is type it in Desmos. So when it says factor, and I have a trinomial, 4x squared plus 8x plus 3. Let's type it in. 4x squared plus 8x plus 3. So there's the first trinomial. So now in my answer choice, if I type in 2x plus 1 and 2x plus 8, we can see if it matches. We see the blue line is not the same as the red line, so therefore the answer is not A. So I try B, 2x plus 3, 2x plus 1. Whoops, not like that, sorry. And the new one, 2x plus 3, 2x plus 1. There you go. The green one is right on top of the red one, so therefore the correct answer has to be B. So easy. So you can continue to do that for number 2. If you do number 2 by hand, I just want to show you, this one only has 2 pieces, so all you have to do is the divide piece. So in this one here, the biggest number I can take out of both of these is a 4. They both have an x. The correct answer is not here. So this one here, it should say 4x and then negative 1x plus 2. Whoops. So in this one here, you can just type it into Desmos and see. And so, well, there's multiple ways to write this. So you could, so like I factored it that way. You have two options here. You can multiply it out, just like we did yesterday, and see if it did this. You can multiply each of these and see if it does that. Or you could just type this into Desmos, and see if it matches. Not too bad. Same thing with number 3. You can multiply these guys out like you did yesterday and see if it's the same as this here. Okay, back to a trinomial. So number 4, easy. If you ever see which expression is equivalent, you can just plug it into Desmos and find your answer. Same thing with number 5, but remember Desmos only likes the letter X. Same thing with number 6. Same with 5, 6. 6 is difference of 2 perfect squares. If you want to do this by hand, this is a perfect square. This is a perfect square. To make a negative, what does that have to be? So you can do that by hand. That's easy. Or you could plug it into Desmos and see what you get. So in number 7, we can't use Desmos. So my little triple star means I can't use Desmos here. I have to do it by hand because it just says what is one factor. They only gave you one factor. So 36 is a perfect square. 49 is a perfect square. To make a negative, one has to be positive, one has to be negative. Which answer choice has one of those factors? Numbers 8 and 9, you have to factor for real. We can't use Desmos here because they only gave you one factor. So they'll do that for one question on the test. It'll say, what is one factor? Well, this is not going to match that in Desmos because it's only one of its 2 factors. So if it says, what is one factor, we have to use the X puzzle, then split the middle, and then take out what they have in common. Okay? So go ahead and try numbers 8 and 9, and then you are done for today.